Okay, so another example of some things we can do with surfaces. So this is part of what we did the other day, but this is basically making a surface from a grid of points, and those grid of points are generated and change their z dimension relative to an attractor point. So I'm adjusting the position of that attractor point, and you can see the surface begins to move around with it. Okay, so what we're going to do first, and I sort of have these labeled in steps, we're going to create a grid of points. Okay, and we're going to create a curve and a point along that curve to act as our attractor point. And that's basically what's going on down here. Then what we'll do is we'll measure the distance between this attractor point and all of the points in this grid that we made. And we'll draw vertical lines from each of these points in the grid. And the length of those lines will be determined by the distance of each of those lines to their attractor point. And so basically then we can take the endpoints of those lines as a grid of points, and we can create a surface from them. Okay. So that's basically how this works. I call this responsive surface. Just one of those quick things that I learned way back in the day, generative components and then Grasshopper. It's one of those classics to deal with parametric design. So let's start from scratch. I'll start a new document. All right, and so I have this curve in Rhino, and I'll go ahead and reference that in to Grasshopper. I'll use the params tab, geometry, curve widget. I can right click, set one curve, go ahead and select this guy in Rhino. There we are. And I'm going to evaluate that curve at a t parameter. In other words, I'm going to place a point along that curve. So I have to give it the t address, the t parameter, that location along the curve that I want to place a point. I'll go ahead and reparameterize the curve, normalizes the start and end of the points as 0 and 1. And params tab, number slider, I'll plug this guy in, and now I can move a point around the curve, well, willy-nilly. All right, so that's my attractor point, and now I need to make a grid of points. And so there's a number of different ways we can make grids of points, but pedagogically what I want us to do is talk a little more about making sequences of numbers, and in this case we'll use series, which we did before. So series creates an ordered list of numbers. The inputs are the first number in the series, the step size for each successive number in the series, and then how many numbers you want to have in the series. Okay, so right now this is set to starting at 0 and step size of 1, 10 times. And what I'm going to do is I'm going to create a number slider, constrain it to integers, give it a minimum of 1, give it a max of maybe like 20. Okay, and I'm going to make a copy of this. I'm going to use it more than once here. All right, I'll plug this in for the step size and then also for the number. Of course, I'm going to increase the number. Here we go. All right, so now we have 10. We can go all the way up to 20 if we want. I can adjust that later on. Same with the step size. So I have a list of numbers, and I'm making this list of numbers. As you remember, in order to make a point, right, I can plug in an x, a y, and a z coordinate. And if I want to make lots of points, then I can connect or feed in any number of x and y and z coordinates in order. So I plug in a list of x coordinates, I'll get a list of points out. A list of y coordinates, I'll get a list of points out. So if I just plug these in to x and then to y, okay, you can see that I'm just getting 0, 0, 0, 1, 1, 0, 2, 2, 0, 3, 3, 0, 4, 4, 0, 5, 5, 0, all the way to whatever this is, 19, 19, 0, right? So 19 comma for the x, 19 comma for the y, 0 for the z. So when going over this in class the other day, I got the feeling that maybe we should just really quickly revisit this. And so what I did is I made a quick PowerPoint talking about data matching, because this is so important. And if once your mind gets it, once you visualize it in your head, it clicks and we can move on. Okay, so this is us just making one point, right? So if I plug in one input for x, one input for y, one input for z, it'll just create one point. It'll match up this one to this one to this one and Grasshopper is very happy. One input for X, one input for Y, one input for Z means it'll have one output of a 1 point. Okay. Of course, this is using the point widget, and I'm just using the note panel to type in some numbers. Okay, so here we are, right? Let's say I do these 5 numbers, sorry, these 6 numbers, it looks like. 6 numbers for X, these 4 numbers for Y, and then I'll leave 0 for Z, right? So there's only one input for Z, is 0. Okay, and so here's what it looks like we get out, right? So here's the X, here's the Y, and here's the Z. Okay, there's several different ways we can do the data matching, right? One is called shortest list. So shortest list means that what it'll do is it'll take the first item and match it up with the first item and match it up with the first item. And it'll do this as many times as there are items in all 3 lists. So as soon as it runs out of items in the shortest list, it's done. And so our shortest list only has 1 item. And so it'll disregard all of these other inputs for X and Y and just match up 0, 0, and 0. Until it satisfies the shortest list, it'll then stop. Okay? And so we only get 1 point out if we're using shortest list as an option. Okay. Longest list is default. And what happens here is that, let's say we have the same inputs for X and the same inputs for Y and the same input for Z. What it will do is it'll satisfy 1 to 1 to 1, right? And then 2 to 2 to 2, our shortest list ran out. And so it'll match up the next input with the last output from the shortest list. And so it'll be 0, 0, 0, 1, 1, 0, 2. Now, because this is the shortest list, we ran out of items in this list, so it's going to refer back to 0 for the rest of the items. 2, 2, 0, 3, 3, 0, right? 4, 3, 0. Okay, we ran out of items in our second list. And so now it's going to revert back to the last item in the second list and the last item in the third list. 4, 3, 0, 5, 3, 0. And so that's how it matches data by default. It's called longest list method, data matching. Okay, we're going to use something called cross-reference. Okay, and so this is what it's doing. It's taking every item in this list and matching it up with every possible combination in all of the other lists. Okay, and so you can see 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 1, 0, 0, 1, 1, 0, 1, 2, 0, 1, 3, 0, 2, 0, 0, 2, 1, 0, 2, 2, 0, 2, 3, 0, and on and on and on and on and on. Okay, until it's satisfied all of the different possible combinations. Okay, and so cross-reference then is what we need to use to get a grid. We'll cross-reference the X coordinates with all the possible Y coordinate variations, okay, possibilities, and then it'll match up with the Z by default, and we can generate a grid, okay? And so what it's doing right now is long list, okay? And so we get like a sort of diagonal pattern of points as it just matches things up 1 to 1 as best as it can. Once we do cross-reference, we'll get a grid, okay? And so I just wanted to make sure you guys could understand that, right? That's kind of what we're doing. We're inputting multiple inputs for X and multiple inputs for Y and 1 input for Z. And so this is how it's sort of matching things up to create a bunch of different values. So here we have 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0, 5, 0, 1, 0, 0, 1, 1, 0, 1, 2, 0, 1, 3, 0, and on and on and on, okay, until it gets to 5, 3, 0, okay? So I hope that maybe helps visualize this a little better. And this PDF I'll post on the website as well, okay? So that'll be available to you just as a reminder in case you need to reference back to it. Okay, and so we need to cross-reference this, so we're going to go to Sets, and we're going to find the cross-reference widget. Just for your information, here's the shortest list widget. If you want to actually use the shortest list method, you would use this widget. We're going to use cross-reference widget, and we're going to plug in for A and B. In other words, this will be the input for X, and this will be the inputs for Y. So this will be the output for our X coordinates and the output for our Y coordinates. And now we end up with, well, we had 20 inputs and 20 inputs for X and Y, right? So now we have 20 by 20 matrix, 400 values, 20 squared, right? So that works out just as we predicted. Now we have a grid of points. All right. So I said we were going to use this point as an attractor point, right? So it has a sort of level of attraction to it based off of how close or how far away it is from these other points that we just created in this grid. And so what we need to do is basically just measure the distance between this point, see this point over here highlighted in green, to all of these points, now in green, all these points in our grid. Okay, and so I can go to the Vector tab, and find distance. It's a ruler in between 2 points. So we can measure the distance between 2 points, or any points, a set of points. Okay, so I can measure a list of points to this point, and we get a list of distances out. Okay, 400 of them, right? Because there's 400 points. So we're going to have 400 distances. Okay, and now one more step. We're going to draw a line using start point, direction, and length. Each of these, we're going to draw a line from each of these points. So each of these points is going to be a start point. And then the direction is going to be the Z, world Z vector, world Z direction, and then axis. And then the length is going to be these distances. Okay, so the lengths will be these distances. So let's start. I'll go to curves and find all the methods we can use to create lines, including line by start point, direction, and length. These will be our start points. And these will be our lengths. All right, now we have a nice set of lines, right? And what we need to do is find the endpoints of each of these lines, right? Because these endpoints are going to be our sort of new point grid, right? That's sort of distorted in the Z value that we can use to create a surface from. Okay, and so I'm going to go ahead and pull start point and end point, so I can plug in a list of curves, any list of curves, and it'll give me the start points and the end points. We just want the end points. Okay, you can see that those are highlighted in green right here. Okay, we're really close. We're going to create a surface now from this grid of points. Okay, and so the way we can do that is we can go to Freeform, right, Surface tab, Surface from Points. And so this creates a surface from a grid of points. Not a big surprise. I think that's what we've been talking about. So I'm going to do several things here. First of all, we need the grid of points. So I'm going to plug in the endpoints as our list of points here. Okay, and we need to tell it the number of points in one of the directions, right? So we need to tell it, we're giving it a list of points, right? It's a big list of points. We need to tell it how many points are in each row so that it knows that once it's satisfied all of these points to move on and make another row. And make another row, make another row after it hits every 20, right? Because that's what this slider is generating. So we're going to use this slider because this is generating the number of points in both directions, right? In X and in Y. Okay, so we'll go ahead and plug that in for the U. One other thing I'm going to do is I'm going to look at the interpolate, this I input, interpolate samples option, and I'm going to set the Boolean to true. I want it to interpolate the surface that it's creating. And what that does is it creates an even distribution of isoparms across this newly created surface, which you can see in green now. Okay, and so look at that. We have a surface that moves around all willy-nilly as we move our attractor point. Okay, so all the changes that we make to the left propagate all the way to the right and inform everything subsequent. So this was part of what we did on Monday. So in the next video, we're going to take this surface and we're going to pull out isoparametric curves in one of the directions. And we're going to use those to instantiate a set of bow trusses. So we're going to combine making lists of numbers and making grid points of, say, point grids, and combining, making lots of lines and things like that, and combining our recipe for our bow trusses. And we're going to sort of add all of these things together in order to make something that's sort of greater than the sum of its parts. So stay tuned for that next video coming right up.